Hello folks, this is video 4 of 5 for Unit 7, an introduction into bonding. And in this video we are going to begin to discuss bond polarity and electronegativity. Electronegativity, also known by the Greek symbol chi, is defined as the ability of an atom within a molecule to attract shared electrons to itself. You can also think of this as the atom's greediness. We discussed a factor in Unit 6 that drives electronegativity, and this is the Z effective. When you've got a very high Z effective, the atom's nucleus has got a strong pull on the electrons. Therefore, the electronegativity trend on a periodic table follows that for Z effective very closely. If you are looking for values of electronegativity on the formula sheet, you can find them just above the periodic table, shown here as Pauling electronegativities. And as you can see, each one of the atoms has got an electronegativity associated with it. For example, fluorine has got an electronegativity of about 3.98. If we look at an example where we have got two atoms bonded together, let's say Y and Z, if they have got the same electronegativity, they will have equal sharing of the electron density, as shown by the little figure down here at the bottom of the video. Therefore, what we see in this example is a non-polar covalent bond because the electron density does not primarily exist on one end of the bond versus the other end. If we now say that Z has got a larger electronegativity than Y, then some of that electron density will be pulled closer to Z. This means that that molecule will have a slight negative or a delta negative charge on Z, and will have a slight positive or a delta positive charge on Y. This result is a polar covalent bond, since more of the electron density will sit on the Z side of the bond compared to the Y side of the bond. If we've got a situation where we have got a metal and a non-metal bonding together, we have got an ionic bond that forms. This is when redox occurs and electrons are being stolen. There's no electron sharing taking place, so in the end we will have one atom that will have a complete positive charge associated with it, and the other atom with a complete negative charge associated with it. We can look at the differences in electronegativity to describe the degree of bonding. This difference in electronegativity is called delta chi. So we would say that, for example, the chi of element Y minus the chi of element Z, and we always take the absolute value of this in order to get a positive number. Looking at this table in your notes, we can use values or approximate values of delta chi to describe the type of bonding. Please note that these values are approximations, they are not set rules. If we've got a delta chi between 0 and 0.4, we will have a covalent bond that will be nonpolar, so neither atom will have a charge associated with it in the bond. If we've got a delta chi between 0.4 and 1.7, we will have a polar covalent bond, and each of those atoms will have some small charges associated with them, a delta positive or a delta negative. Finally, if the delta chi is larger than 1.7, we will have an ionic bond, and each of those atoms will have full charges, positive or negative, associated with them. In video 5, I will work through question number 2 that's shown in your notes, but I strongly suggest you try to work through this question 2 before you watch the final video. This concludes video 4 of 5 for Unit 7, an introduction into bonding.